Hi everyone, this is David from the Myriade team. Today we're going to be taking a short look at comparing side by side Metabase's new AI integration Metabot with our own in-house developed AI agent for data analysis, Myriade. So, to do that, what we've done is we've taken an open source data set that's sourced from a Brazilian e-commerce platform called Olist. It's a data set that has data ranging from 2016 to 2018. It's pretty much a Brazilian Amazon. And the data sets that are contained are pretty typical. So you have your orders, including the contents in terms of products of those orders, connected to a product category data set. We have delivery information tied to the orders, order reviews, order payments, and then we have some seller and customer data that has that's tied also to geolocation data. So what we've done is we've taken these raw CSVs, each of these individual data sets, and uploaded them into a Postgres database, and then we've connected them to Metabase and to Myriade. Just to show you quickly, we're working with the same data sets. We have the different tables I've just mentioned here, and if I go into, for example, the customer data set, you'll have customer ID, unique ID, zip code, customer city. If I go into Myriade, into the editor, you'll have the same data tables, and we already are in the customer data set. You've got your customer ID, unique ID, your zip code, and your customer city. Right, so what we're going to be doing is asking a set of questions. We're going to be asking some basic questions first, which is some basic discovery questions. What do you see in the database? Some exploration, which tables contain order values, for example. We're going to ask both tools to create a visual, so show me a graph with the top 10 products with the most delays on delivery, and then we're going to go into some more complex questions to try and really test how far these AIs can go, stretch them a little bit. So we'll be asking an open question, which would be, in a business case, probably used for root cause analysis following an event. Looking at complex questions that require multiple table joins, data aggregation. We're going to be asking an estimation question, so asking the AI to sort of forecast based on current data. And then at the end, we'll be asking a trick question to see how both AIs react. Right, so let's get into it. We're going to be asking our first question. I'm going to launch it in Myriade first because it might take a minute to load. So that's doing its thing. And then I'm going to go into Metabase, Command K, and I'm going to say hello just to open up the interface. And I will paste my question here. Right, okay, so that's operating at the table level. I'm going to go back and go to the full data set. Let's see what it can see. Don't see any data sources available to me in the database right now. Why is... right, okay, no, I know why. So for those who've never used Metabase before, when you upload raw data into Metabase, to be able to analyze it and probably to be able to analyze it with Metabot, you need to create models first. So I'm quickly going to do that, and I'll be right back. I might speed this part up. I'm going to have to go into the data schemas. Right, I'll do that quickly and then we'll get right back into it. Right, so I've successfully created my data model. So I just essentially used the data schema that you have here. And we're pretty much ready to go. I've reset everything, so let's launch that question into Metabot. And I'll do the same in Myriade again. Okay, so right, so now it's correctly seeing all the different data sets, and it's able to identify the different columns. It's a combined data set from multiple sources related to orders, products, sellers, etc. Right, so it's done a good job of identifying what the data is. These fields include identifiers, timestamps, etc. Okay, good. Let's see how Myriade has done again. So it's done the same thing as in the previous response. Essentially, we have it's identified what the data is. It's actually identified, I don't know if I mentioned this the first time because the time lapse in creating the model was pretty long, but it's managed to identify that it's a comprehensive data set for a Brazilian marketplace, which I'm assuming it's managed to infer from the fact that there is a product category name translation that's in Brazilian originally. So I would say that's probably a point for Myriade, although for the purpose of what we were asking, I suppose it's given us the same. It's been able to identify the data sets and what they contain. Myriade's just given us a bit more granularity, decomposing the tables in terms of core business tables, transaction, and reference tables. And maybe a bit more business context comprehension, but I'm going to say that's pretty much equivalent. Now let's move on to the exploration question. Which table contains order values? Let's see what happens there. Right, the order values are contained in the field name price. In the current model you're looking at, this field represents the value of each order item. That's correct. Additionally, there is a payment value field in the order payments dataset within the same model, which represents the payment amounts for orders. That's correct. So the order values can be found primarily in these fields within the combined model, price in order items and payment value in order payments. If you want to, okay. And for Myriade, so it's identified the two different tables. Order items contains price, individual item price, and freight value. Right, so that's interesting. It's managed to decompose the components of what we would consider, what did we ask? Was it total order value? So that's already a bit more granularity there. And it's identified the second table, which is payment level. So payment value is actual payment amount, whereas the order items table is individual item price and shipping cost. Interesting. And it's identified some key differences. So items table shows what was ordered, price plus freight, and payments table shows what was paid, which it can include installments. Right, so it's managed to, I don't know if it's in this, no, it's not in this table, but it's managed to infer that and understand that there are different methods of payment, which is actually a feature of the data set. So that's quite interesting. And it then gives some guidance for total order value analysis. You'll typically want O-list order payments grouped by order ID, and for product pricing analysis, use O-list order items dataset. That's interesting. So that's more granularity for Myriade. I'm going to have to give that point to Myriade. Next question. We're going to ask it to create a graph. Here, I would expect Metabase to blow Myriade out of the water. They've always been the king at data visualization, but let's see where this takes us. It's the joys of live demo. Right, to calculate delivery days, so it's offering to do an SQL query, so I'm going to say yes. Calculating delivery days involves, right, so it's opening up the SQL panel and it's asking me if we should continue. I'm going to say yes again. Please write the SQL. How's Myriade doing? It's thinking. Okay, it's managed to deliver the graph, which is great. Top 3 categories, 920 counts. Health Beauty has fewer absolute delays than bed bath table. It has the highest delay percentage. So we've got some notable patterns inferred as well on top of giving us the graph. Most categories show delay rates between 7 to 9%. Average delays are relatively short. Auto category has the highest average delay time. Interesting. This analysis shows that larger product categories naturally have more absolute delays, but the delay rates are fairly consistent across categories, suggesting systemic delivery challenges rather than category-specific issues. Right, so it's inferring a lot of business context here, which is really interesting. All this based off of raw data that we didn't set up a schema for as well, mind you. So that's interesting. Right, so I've run the SQL query on Metabot, and I haven't got the graph. Let's see, can you show the data as a graph? One thing I'll give to Metabot is they've really done well, because they had obviously a whole pre-existing visualization and dashboarding interface that has always been their strength, and they've managed to really quite seamlessly integrate Metabot into their interface, so kudos for that. Right, so we have counts, but it's not giving us the precise products, but what I find is only giving us the product IDs, but what I find really interesting is, I'm just going to ask Myriade, can you provide product IDs for each of the top 10 products listed. I'm going to compare because it will take too much time to investigate or have it modify the graph here, I'm afraid. But one thing I find really interesting is the delay count is hugely different. We have 47 on the highest product, whereas here we have 920. Considering there's 100,000 orders in the data set, I would lean more towards Myriade as being the source of truth. But let's see, how have you arrived at this delay count? What data and methodology did you use? I'm going to ask the same thing to Myriade. Let's see. Right, see the confusion. My video showed the top 10 product categories, which delay, and that. Here are the top 10 individual products by product ID with the most delivery delays. Aha, that's why. So, I was wrong. It was not necessarily Myriade. Well, the difference is because I'm assuming it's done right. So it's done in terms of products. What had we asked? The top 10 products. So that's why. So actually that's a point for Metabot. I misspoke because it was able to figure out that it was products and not categories, which makes sense actually, and which is what we have here. Yeah, these are categories. Right, makes sense. Let's see if they found the top 10, same top 10. We have 55 counts. Metabot has a few less, but the product IDs seem to be, yes, they're identical, right? So they're finding the same thing, which is reassuring. And the methodology, so it's taken delivery dates from the order data set, it's linked orders to products, and it's identified product categories, which was false, and it's taken the translation to translate to English product names. A delay occurs when order delivered customer date exceeds or is bigger than order estimated delivery date. Right, and that makes sense. Let's see if Metabot's done the same thing. Delay days is the actual delivery date minus the estimated delivery date. Right, so that's slightly different, but you arrive at the same result. You should arrive at the same result at least. Keep only records where delay days is greater than 0. Right, so it's the same logic essentially. Key assumptions it's made. Delay is any delivery after the estimated date. Yep, estimated delivery date is the customer's expectation. Actual delivery date is when customer received the order. Potential limitations it's accounting for. It doesn't account for weekends, holidays in the delay calculation, which makes sense because those are not business days. So that makes sense. Treats all delays equally regardless of magnitude. Makes sense, and doesn't consider if early delivery might offset late ones. Fair enough. Count delays per product, group the results by product ID. Okay, this approach gives you that. Alright, so I think we can say safely that's a pretty equivalent. Maybe on one hand, I'm tempted, let's give the point to Metabot because they figured out on the first go that it was top 10 products and not categories. And the results that we've arrived at seem to be pretty similar between both tools. So I'm going to give that point to Metabot. Right, so now let's get into the more fun questions. We're going to ask an open question, which is also a bit of a trick question in reality because, as we mentioned earlier, the data set is only 2016 to 2018, but we're asking why sales dropped last week. Let's see how both tools fare. I've created a dashboard that may answer your question. Let me know if you need anything else. Right, I might have to exit here to be able to see it. Discard changes. Let's try that again. Right, I'm going to check Myriade in the meantime. So, why did sales drop last week? I can't analyze sales from last week because this OList data set is historical data from 20, right? So it hasn't fallen into our little trap. What it can analyze instead, if you're interested, is sales patterns I could show you, weekly sales trends, sales drops during specific historical periods, day of week sales patterns. If you have access to current sales data, okay, let's reformulate then. Why did sales drop in the last week of historical data? I've created a bar chart. This is Metabot. showing the total sales by product category and seller state for last week. This could help identify which categories or regions. Great, okay. We're getting no results. Take me to the chart. My typing is not going well. No results. Right, okay, so it's trying to find data, of course. So it's fallen into the trap. It hasn't been able to identify the difference. I'm going to ask, why did sales drop in the latest week of data you have in history? In the data history. Right, Myriade. Yes, there was indeed a dramatic sales collapse in the final weeks of the historical data. Here's what happened. We've got a graph. The sales drop pattern. Peak performance, August 2018. And then it drops the next week by 42%. Dramatic collapse. Okay. Likely reasons for this drop. Dataset collection end. This appears to be when the data collection stopped, not an actual business decline. Interesting. Platform migration. OList may have been transitioning systems or ending this data sharing arrangement. Again, understanding business context. Research project completion. The dataset was likely created for a specific study period that ended in August. It's managed to understand that it's a data set for that was, let's say, artificially created or at least truncated. The final weeks might represent incomplete data capture. Right, key evidence, the drop is too extreme, 94% in 1 week to be a natural business decline. Orders drop from 1,800 to 2 to 7 almost overnight. The pattern suggests data collection cessation rather than actual sales performance. Right, really interesting. Metabot has tried to analyze the latest week of data. The analysis breaks down sales by these dimensions to identify which product categories or regions experience the biggest decline, which would explain the overall sales drop. If you'd like, I can help you explore specific categories. Would you like me to do that? No, I don't really have... Right. For the purpose of keeping this video short, I'm just going to stay at that. I'm sure we could go deeper, but I'm going to have to give that point to Myriade. Right, so now let's go into a complex question. I'm going to go back to my model, make sure we don't bias anything. Where you are in Metabase can be quite important for what you ask Metabot, as a side note. So this question requires multiple joins and aggregations. Let's see how it does. What product categories show the most delay in delivery, and how does it impact its average rating? Right, so Metabot needs to do some SQL. Say yes. Agree. Okay. This one I take the fourth. Take a bit. Thank you, please. Okay, great. So there. Okay. Agree. Right, so Myriade has done it. It's written the SQL. Here's the analysis of delivery delays by product category and the impact on customer ratings. So, top 1 categories with highest delivery delays: fashion, underwear, beach, 12% delay rate, massive rating impact. On-time orders get excellent ratings, but delays cause severe dissatisfaction. Audio, same thing, major rating drop as well. Customers are very sensitive to audio product delays. Books, technical, same thing, with a moderate impact. Key patterns, highest rating impact from delays is the fashion products, the musical instruments, and then the audio. Most volume with significant impact, health and beauty, which is a different category, and electronics. Critical insights, high-risk categories are fashion, audio, and musical instruments that show devastating ratings drops when delayed. Business impacts, categories with both high delay rates and severe rating impacts should be prioritized for logistics improvements. It has an insight into customer expectations and then makes a recommendation. Focus delivery improvements on fashion, underwear, beach, and audio categories first. They have the worst combination of delay rates and customer satisfaction impact. So a really good mix of analyzing the data and also providing business context relevant response, which I find very interesting. I've got an error on the SQL query, so Metabot is just going to quickly fix it, and we'll run it again to get our answer, hopefully. Right, so we have a table response. What can you infer from the data you have generated based on the original question? Right, here we go. Most of the data, here are some possible inferences. Product categories with higher counts of delayed deliveries tend to have an impact on customer satisfaction as reflected in their average review scores. If a product category has many delayed deliveries and a lower average review score, it suggests that delivery delays may be negatively affecting customer experience and ratings for that category. Conversely, categories with fewer delays. Right, so it's not really saying anything that we wouldn't expect. Let's say which products are most sensitive to this. And then I'll be moving on to the next question to make this as short as possible. We're going to move on to the estimation question, so ask it to forecast. I'm going to send that to Myriade so it can do some thinking while we finish that. To identify which products are most sensitive, and then we would look for products that have a higher number. Right, so we'd have to write another SQL query. So I'm not going to go into that, but that's an easy point for Myriade, I think. Let's move on. I'm going to go back to my model just to make sure I'm not biasing anything again. Okay, and I'm just going to start a new Metabot conversation so it's really all clean. Trying to give it all of its chances. Again, I want to keep things balanced. Metabot is very new. Metabase is primarily a BI and dashboarding tool, and they're very good at doing that. Obviously, Myriade is developed specifically for the kind of analysis that we're doing here. To address your question about the estimated impact on product ratings and number of 5-star reviews, I need to clarify a few points and check the data availability. I assume delivery time can be calculated as the difference between yes, product ratings. We have the review score field, which seems to represent product ratings. Is that the rating you want to analyze? Yes. This would be the count of reviews where review score equals 5. Yes. Time period should this analysis consider all available data or a specific period? Yes to questions 1 and 2, and question 4, all available data. Do you want a correlation analysis or predictive model estimate? I want a predictive model estimate. Right. So I suppose that's a good thing. Verifying what you mean and clarifying before replying is important. Obviously, you don't want to trust AI blindly. It's asking me for an SQL query, so I'll say yes. So Myriade's done already. Here's the estimated impact of a 10% delivery time reduction. Key impact metrics: delivery performance improvement. 935 orders would shift from delayed to on time. That's a 13% reduction in total delayed orders. The rating impact estimated would be quite minimal, 0.002. 5-star reviews impact would increase by 0.9%. The business value, customer satisfaction, 935 fewer frustrated customers per period. These customers would experience rating improvements from 2.26 to 4.21. The review quality could significantly improve product rankings and social proof. Better conversion rates from improved review profiles. So again, it's putting it into business context. ROI considerations: the 13.1% delay reduction might seem modest, but affects the most critical cases. Focus should be on categories with highest rating impact, so it's linked back to our previous question. And it gives a recommendation: a 10% delivery time reduction would yield meaningful but incremental improvements. For maximum impact, target the specific product categories with highest delay sensitivity rather than across-the-board improvements. So this is, I hope you can tell, this is a very granular and business context-aware response that it's giving us. Metabot is still trying to figure out the SQL. To proceed, I can either provide average review scores and counts of 5-star reviews grouped by the existing date fields separately, or help you navigate to the SQL editor where a more complex calculation like delivery time and difference and predictive modeling can be done. Okay, let's try that, but I might have to move on to the next question, otherwise this video is going to be very long. Okay, put this into Myriade while it does that. This is the trick question, so I'm asking it to compare data it doesn't have versus data it doesn't have. Let's see what happens. Right, so Metabot has given us a reply. Average ratings and 5-star review counts by delivery and purchase dates. It still hasn't really given us our reply. Direct calculation of delivery time difference isn't supported here. This is an estimation, right? We're not really. I'm gonna have to give that point to Myriade. Sorry, Metabot. Let's see how it does with this trick question now. Right, sorry, let me try that again. Yep, let me go into the model. Start that again. And here we go. Right, so Myriade is done. Here's the year-over-year sales comparison from the historical OLIS dataset. It's managed to figure out that that data didn't exist, and it's done the 2 last years of data it has instead. Important context, data coverage limitation. It has full 12 months data, only 10 months, and then a partial year. So it hasn't necessarily alerted us that it doesn't have the data of last year. It's not aware, in terms of, I guess, temporally, in terms of time, but it has given us, it's flagged limitations in the data set, and then it's given us the performance analysis, key insights, the business showed healthy growth, blah, blah, blah. Right, so that is good. I created a bar chart comparing total sales for last year, so it's fallen into the trap, 2024 versus the previous year, 2023. Let's see what data that's created. No results, of course. Right, so that's another point for Myriade. I think one thing that jumps to attention there is that the use case seems to be different for Metabase's Metabot. It seems to be an AI that helps you write SQL, potentially generate graphs that you can then incorporate into dashboards. But it's not necessarily a tool for deep dive ad hoc exploration or asking root cause identification the way Myriade would be. So I would say 2 different tools for different purposes that can be very complementary potentially. On the setup side of things, if you're already in Metabase, obviously you'll have Metabot directly there. There's no implementation required as long as you have the Enterprise or Pro plans. For Myriade, you would have to install Myriade either locally or use the cloud version to connect your database and then be able to use it. So if you're already in Metabase, it's a bit less setup than Myriade. So that pretty much wraps it up. Last thing, we're considering developing a connector or an integration for Metabase so that you could plug Myriade directly into Metabase. If that's something that would interest you, let us know in the comments, and if we get enough replies, we will look at developing that pretty quickly. All right, thanks guys.